Hello everyone and welcome to another episode of TD202. In this episode, we will draw another simple isometric drawing, but this time it will consist of lines that are not in line with any of the isometric axes. Stay tuned. Okay, so these are the two shapes that we are going to draw today. And if you notice, there are some lines on each shape that are not parallel to any of the axis lines, whether it be the x-axis, the y-axis, and the z-axis. Now, this line is parallel with the x-axis, so is this, so is this. The y-axis, this line is parallel, this line is parallel, this line is parallel. For the z-axis, this line is parallel, this line is parallel, this line is parallel, this line is parallel. So that leaves us with these two lines, which are neither parallel to the x-axis, the y-axis, or the z-axis. Let's look at this other shape. X-axis, y-axis, z-axis. This line, this line, this line, this line, and this line, these lines are all parallel to the x-axis. Y-axis, this line, this line, this line. The z-axis, this line, this line, this line, this line, and this line. So that leaves three lines that are not parallel to either axis, or either of the axes, singular axis, plural axes. Okay, so we already know that for the z-axis lines, our set square can be used to achieve these slopes. Likewise, x-axis, our set square can be used to achieve this slope. Y-axis, or set square, can be used to achieve this vertical line. So how do we approach the lines that we cannot use this set square for? Meaning the lines that don't correspond with either of the three axes. We are going to simply ignore those lines until we have no choice but to draw them. Let me demonstrate using the first drawing. So, as usual, for simpler drawings, I recommend the beginner students to firstly draw your axes lines. These are your construction lines that are used as a guide for the shape. So X, Y, and Z. After we have done that, we can go ahead and measure all the measurements that we are familiar with. For example, 25 on the z-axis, 70 on the x-axis, 45 on the y-axis. Remember the concept of transferal of measurements or calculating measurements. Once the lines are parallel and they are in a parallelogram shape, the lines are equal. So 45 here. We are going to proceed to draw the other side of the shape. So what we are doing is basically drawing the parts of the shape that we can ascertain by just using the set square. So this part of the shape measures 80 millimeters. Then this part of the shape that I'm about to draw measures 40 millimeters. So what you notice is that this point is connecting to this point. I'm going to brighten what I've done so far so that you can more clearly see what I am saying. But even though I'm brightening now, I'm urging you to brighten only when you have completed the drawing or outlined the drawing in terms of sketching it out with the guidelines before you brighten. Once you have become an expert at this, you can brighten as you see the need. I'm just brightening so that you can see the shape being carved out for better demonstration. So as you can see on this shape over here, there's a line connecting these 2 points. So I'll just simply take my set square to create that line. It's as simple as that. You are going to do the same for the line at the back. So we're going to continue to draw all the points that we have already established. We have already established that this measurement is 25 millimeters. And as such, we can measure. And the same principle goes. We can go ahead and connect the points because they have already been established. So by finding these points, we can establish the line. Now, this principle can be applied to every shape that consists of lines that are not parallel to either the X, Y, or Z axis. So there you have your first shape. I'm going to proceed to the second shape, which is slightly more difficult. It's the same principle, but this line at the back, we have to get it. We have to achieve it by another means. I'll show you. So as usual, I'll produce my axis lines, X, Y, and Z. After which, I am going to measure the axis lines to start off the drawing. Now, I already know that this is 65 millimeters. This is 90 millimeters. And this is 50 millimeters. In isometric projection, we can approach drawings by drawing using the overall length, width, and height before carving out the shape. Alternatively, we can draw the lines based on the direction and the length. So we can approach it both ways. So here goes. I could have just drawn a line that measures 30, but I realize that this line and this line is parallel or in line with each other. Okay, so let's get to the fun part. I should have mentioned that this portion is at the midpoint of this object. Therefore, 45 millimeters is on each side. So we have to find the midpoint, which is 45 millimeters. Then, as seen here, we are going to measure 30 millimeters. So once we find that 30 millimeter mark, we know that these lines should touch here. So let's go ahead and find the other two lines, 30 millimeters from the respective edges, and we will find them here. All that's left to do is for us to connect the points. Now, this part is relatively easy compared to getting the last line, because at the back here, we are not able to see the point that it should connect to. There are two options that you can utilize in order to get that. I'm going to show you both options after I've brightened so that you can really examine what's going on here. The reason why I'm going to show you both options, each option may be the better option depending on the drawing that you are attempting. Give me a few more minutes or a few more seconds to complete the brightening process to a point where I can move on. Okay, so the first thing you can do to achieve this slope is to measure the entire length of the object, or width rather. So we know that this object is 50 millimeters in width. So we will draw a construction line and measure 50 millimeters. Once you have done that, this point can be connected. You're basically transferring the measurement. So the only part of this V that I've drawn that I'm interested in is the visible portion, which is here. I didn't have to draw all of that. I was just drawing it to show you the shape or to demonstrate the shape. Alternatively, you could have simply transferred a parallel line, and this is how you transfer a parallel line. You set one set square in line with the line that you want to transfer. You take another set square, or this could be a straight edge such as a ruler, place at an other edge. It can be any other edge, but you'll use the more convenient edge of the set square. Slide the measurement to the point that you are aware of. So once you have done this, I think I've shifted the set square. Once you have done this, you will be able to transfer your parallel line. So there you have it. This line is parallel to this line. At least it should be. It's not showing, it's not proving to be parallel. This means that there is some inaccuracy with my drawing, but it should be. So this is the second method that you can use to transfer this line to here, given that this point wasn't established. Alternatively, you could have just established the point that similar to the way that I did. So this is how to approach isometric drawings that include lines that are not parallel to either of the axes. I hope you grasped this concept. Have a wonderful day. Please remember to like the video, share the video, and subscribe to the page. Share the knowledge.